Alright guys, welcome to today's video. Today we're going to be focusing on classifying quadrilaterals using the coordinate planes method. Again, we're going to show that mastery in class by scoring at least an 80% on an exit ticket. Hopefully you have the note sheet in front of you. If you don't, take out a blank sheet of paper and we'll get you a fresh copy tomorrow. Now, the one thing we need to keep in mind when we are solving these, when we talk about slopes of lines, we need to remember that in order for lines to be perpendicular or meet at a 90-degree angle, the slopes have to be the opposite reciprocals. So in this case, if I had -1/2, my reciprocal would be 2. If I have 3/4, my opposite reciprocal would be -4/3. If I want to prove lines are parallel, so they never intersect each other, we need to make sure they have the same slope. Now, this becomes important because today we're going to be focusing on classifying quadrilaterals by looking at distances, by looking at slopes, or by looking at the coordinate planes. And in order to prove some of our shapes, we need to prove that lines are parallel, or we need to prove that lines are perpendicular. Now, if we look at our first one, it says determine all the categories given the slopes and distances of the quadrilaterals. Now, the first thing I'm going to look at is I'm going to look at all my distances. Well, if I look at all my distances, they're all exactly the same. So that gives me two options. That tells me it's either a rhombus or a square, because those are the most specific we can get that have all congruent sides. Well, now I need to look at my slopes. First thing I notice, slope AB and slope CD are parallel, and slope BC and slope AD are parallel, which is good. So we still have rhombus and square because opposite sides are parallel. Now, we need to focus on the angles now. If it is a square, we need 90-degree angles. So I'm going to look at where my two lines meet, and I'm going to look at where my other two lines meet. I need to ask, do I have opposite reciprocals of each other? Well, 1/3, my reciprocal is 3/1, and the opposite of being positive is negative, so -3. This tells me this side meets at a 90-degree angle. Well, if it meets at a 90-degree angle, that means it is a square. So my general classification for this is a square. However, when it says all, it's also going to be a rectangle, a rhombus, a parallelogram, and a quadrilateral. So if it asks for just one classification, it's a square. When it says determine all, it is a square, and it is everything above it that you can follow along those family tree lines. Now, we want to talk about how to use Desmos to be able to prove what shape this is. And in this case, it's saying it's a parallelogram. Now, first things first, we need to look at our shape. So I'm going to add an item, and I'm going to insert a table. Now, you're going to treat the table just like you would, putting your points A, B, C, and D. But the one thing we always want to do, we want to go back and put A in twice. Now, if I click and hold this circle and connect my lines, now it connects all those lines. If I were to not include A, well, it only connects 3 of the lines, so make sure you include that last one. Now, being a visual learner, I'm going to make my life easy, and I'm going to put in my points, but I'm also going to label them and call it A, so I know where point A is. I'm going to do the same thing for all my other points. That way, it makes it very easy on the graph to see exactly where each point is. Now, when you go to do this, the one thing you need to be mindful of, capitalization matters. I made all of my points lowercase, so when I go to use those points later, I need to use lowercase letters. If you want to use capital letters, that's fine. Just when you go to use those letters later, make sure you use capital letters. Now, the things we need to prove for a parallelogram. First, we need to prove that opposite sides are congruent. Then we need to prove opposite sides are parallel. If we can prove those, then we're good to go. So I'm going to use Desmos to help me out a little bit here. And I'm going to do my distance formula, and I'm going to do the distance from A to B. So I just put A comma B, but again, that's where the capitals come in play. And I'm going to do the distance from D to C. Now, I do those first because those are opposite of each other. They're congruent, so that works. Well, now I need to do my other side. So now in this case, I'm going to do B to C, and I'm going to do D to A. they're also congruent. However, they're not congruent to the first set, but that's okay because a parallelogram, all the sides are not the same. So now that we've proved opposite sides are congruent, we're good. Now to prove they're parallel, and I'm going to zoom in just a little, we need to prove that they have the same slope. So if I do the slope from A to B, I'm just going to do rise over run. So I go up 1, 2, 3, 4, 5, 6, and I go over 2. So my slope of AB is 6 over 2, which is the same thing as 3. Now I'm going to do my slope of CD. Again, rise over run. 1, 2, 3, 4, 5, 6, and over to the right 2. Well, that gives me 6 over 2, which is 3. So those lines are parallel. But now we need to check the other side as well. We can't just stop because we have 2 sets of parallel sides. So if I do the slope from B to C, I go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 4 over 6, which is equivalent to 2/3. And my last side, I'm going to do AD. So again, rise over run. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So 4 over 6, which is still equivalent to 2/3. So that tells me those 2 sides are parallel, which makes this a parallelogram. Now, if you did not want to do rise over run for your slope, you can also do the slope formula still. You would do y minus y over x minus x. That will still work. Either way, you need to check your slopes. Please bring your notes and any questions you have to class tomorrow. I look forward to seeing you then.